Good evening, everybody. We have a function that depends on the ceiling function and the floor function. So let's just do a quick review of the ceiling function, which is not seen quite that frequently. Is the floor function the ceiling of 12/5? 12/5 is a number between 2 and 3, right? So its ceiling is just intuitively 3, and the ceiling function is the least integer that returns a number greater than the input argument. It's the least integer that is greater than the input argument. And a similar statement for the floor function. I won't go over that. Okay. Now we have this strange looking situation here. We have g of x defined to be f of x minus this strange object right here. And then we're supposed to evaluate this function, this newly defined function at 13,703. Now notice that you could probably do this directly just fine, but you would have to go to the trouble to multiply 13,703 times 26 by hand. Using a calculator, of course, is cheating. All right, and so you can do it. You can definitely do this problem without any intermediate results. But this particular type of function has a very unexpected property, and let's get into that unexpected property. Some of this is certainly unmotivated, but if we're going to try to make a proof here we're going to try to prove this object is actually periodic, okay? So we pick 5, not surprisingly here, and see what happens. And when you do that, folks, 5 over 5 is just 1, and the ceiling of that is just going to be 1, of course. And so there's the 1 right here, 25 right here. I won't spend too much time on this, but we learned that f of x plus 5 is equal to f of x plus 26. Okay, now let's see where that leads us. Okay, so now I told you we wanted to show that g is periodic, so let's try out g of x plus 5. And you can see here, I won't spend too much time talking about what happened here, but it does work out. G of x plus 5 is equal to g of x, and you guys can verify that I didn't make any mistakes right here. I think I'm almost certain I got this right, so I don't think there's anything wrong with what I've done here. But what does this do for us? This proves to us that g of x is periodic. It repeats every 5 units, okay? So g of x is periodic. And we can use this periodicity to simplify the computation. It's periodic, if I got the spell right, okay? So we know that. Now, and also there's no constraints on x here, so it holds for all real numbers x, okay? So we can conclude this is true, and I'm just going to give you a brief justification, not a super rigorous proof, but let's say we were looking at g of x plus 10. Okay. Now notice right here, I'm saying that this is true for 5m, where m is, and I should tell you that's an integer. Z stands for Zahlen, which means to count in German. Okay. So this holds for all m. I'm just going to show you one special case where m would be 2 right here. Now, so we can rewrite this. It's g of x plus 5 plus 5, right? Let me get this a little neater there. There we go, folks. I hope that is cool there with you, what I've done. Okay, g of x plus 5. Now, remember, this is for all x, so x plus 5 is just some other real value, right? Okay, but what is this equal to? This is equal to g of x plus 5, right? Based on this result right here. We just let x be replaced with x plus 5, okay? So this would be just g at x plus 5, but we already know from this work right here that that's equal to g of x, right? And this type of reasoning would go on, I guess you can call it inductive, right? So you see we did it for one multiple of 5, and that same kind of thing would happen. There's a formal way to make it better than this, but hopefully this is very believable what happened right here. G of x plus 10, where this would be 2 times 5, just gets mapped to g of x also, okay? So let's see how this helps us. Now, remember, this was our original thing we were wanting to evaluate, g at 13,703. Well, guess what we do? We divide 5 into 13,703, And we have this is in the form of 5m, right? This is 5 times m, right? 5m. And so it just gets sent to G of 3, which is a much simpler computation than this, right? So let's see if we can get that done on the very next line. Now, y'all, this is f of x right here. Remember, f of x is just the ceiling of x over 5 plus the floor of 5x. Like that, okay? And so that's where all of this comes from, folks. We multiplied the 3. Remember, it's equal to G of 3. Much simpler. All right, so 3 times 26 is the 78, y'all. And that becomes 2/5. And again, you guys can verify. I double-checked the calculator. Pretty sure I got it right. And so the answer to our question is 2/5. Now, again, I bet some of you, if you took the time, if you felt like it, you didn't want to watch all of this, you probably already know the answer is 2/5. But again, if you, let me go ahead and circle this, because I'm kind of proud of it. We exploited the periodicity of this strange function that we were presented with. So this is equal to 2/5, and that's the answer. Now, again, you're saying to yourself, right, you didn't need that. And you're right, you didn't. It's very easy to divide, you know, this is the easiest part right here, just 5 times this number, right? All right. But then you still, guess what? You have to plug it, substitute this large number into here, multiply by 26, divide by 5, and see if it all washes out. And it will, but again, you're minimizing your large computations by establishing the periodicity of this thing, right? This is periodic, and the periodicity allows us to do a relatively simple computation. Okay, and you guys may want to experiment with other integers. This came from an ARML problem where they did x over 3 times 3x, and they got, I think, like 11 over 3 here. You can, but if you go through all this, it all works out nicely. And I think there's a lot of problems that could be formulated from this sort of thinking. You know, this is not the best example of how to exploit the periodicity, but there's probably harder problems, much harder problems where the periodicity makes the problem quite easy. But in any event, that is it. We got it done, and thank you for viewing.